Next, we shall find out the probability of error for optimum filter. As you already shown, that probability of error is given by this expression, and as you already assumed that noise is Gaussian in nature, so we'll use the Gaussian density function. So that probability is correspond to this to infinite density function d of n0. Note here, we are considering capital T, not small t, because this noise component is after the sampling value. So we'll use the expression for the Gaussian distribution. Why I'm taking this limit? It is because you see the distribution, that is noise distribution, and that is correspond to x01t minus x01 minus x02 by 2, and we need to determine this to infinite this area, so that's why limit is this one. And from Gaussian distribution we can write PE equals note here that we are considering sigma as it is a generalized Gaussian noise. We will not consider sigma is equals n by 2 bar or something because this noise is Gaussian, generalized Gaussian noise, and it is not white noise. Again, filter transfer function is totally unknown to us. That's why output or density function cannot be determined directly. Now we'll consider this part as y square, like the previous case, n0t y square. So from this, n0t equals sigma root over 2 y, or d of n0t equals sigma root over 2 dy. Now as n0 tends to infinite, y tends to infinite, and n0t tends to this lower limit x01t minus y tends to this by sigma root over 2, y tends to x01t minus x02t divided by 2 root 2 into 2 root 2 into sigma. So we'll change the integration limits and change with respect to y. So now probability of error PE equals so you can write this as 1 by root over pi sigma will cancel out, root 2 will cancel out, so 1 by root over pi x01t minus x02t by 2 root 2 sigma to infinite to the power minus y square dy. Will take 1 by 2 and multiply it by 2. So that is a standard form of expression. So that part is the error function. As we already know that that part is the error function, so we can represent it by 1 by 2 ERFC complementary error function x01t minus x02t divided by 2 root 2 sigma. So that is the probability of error calculation for the optimum filter.